Yes, sir. Good morning.
Yeah. So please wait for a couple of more minutes. People are joining.
Okay, sir.
Hi, sir. Uh,
Swamsi,
I haven't received that Scala material, sir.
today you will get it, sir. Have you sent an email?
Yes, sir.
Okay, today you will get it, sir. By today you will.
And the previous one also I haven't received. That's why. Yeah,
No, only one mail I have shared with all the members.
yeah. That and I am missing there, sir. Can you please help me that?
Yeah, I will share.
Yeah, thank you.
Yes, sir. Let us proceed. So today we are going to start with the Spark framework. So what exactly we have discussed about the Spark? So like Hadoop, what is the main purpose of Hadoop framework? If you look at the big data technology, Hadoop, it is meant for big data storage and processing. Whereas Spark, it is only meant for processing part of the data alone. So if you ask me, in Hadoop also we are doing the processing, then what is the advantage that we are gaining out of Spark processing? But Hadoop processing is always going to be with the disk-based processing. Okay, always, either we are using a map reduce mapper phase, sort and shuffle phase, or reducer phase. They are all going to make use of HDFS only predominantly, either to read the data or write the data. They are completely making use of HDFS only. So that is where it is a disk-based processing system. But in against to the same, our particular Spark, so it is a in-memory processing system, in-memory processing framework. In-memory processing framework. What do you mean by in-memory here? Cache-based processing system, cache-based processing framework. Meaning here it has the Spark has the capabilities to keep the data, required data into the memory, in-memory cache, and from there it will repeatedly read the same data and to process the same data. So because of this in-memory kind of the processing from Spark, there's a lot of difference from the processing speed as well. For example, in one particular use case, if Hadoop is taking 100 minutes of the time, same use case, same processing and same output I will get in 1 minute of time as well. Using Spark, the same output we will get it in 1 minute of the time only. Okay, so that is where the beauty of Spark framework. So what is the conclusion here? Spark is in-memory, meaning cache-based. Spark is a in-memory or cache-based cluster computing framework which is exclusively meant for processing part of big data. And Spark-based Spark processing performance, processing speed is 100 times faster than Hadoop processing. Okay, yeah. If we can keep all the required data in memory or in cache, if we can keep all the required data in the in memory or cache, so that is what we are going to do here. Okay, yeah. Now, so Spark is only meant for processing, but you can ask me immediately one more question. Gopal, Hadoop is meant for both the storage and the processing. For storage also, there is a proprietary component in our particular Hadoop. So that is none other than HDFS. So in order to process the data, either we are using MapReduce or PIC or Hive. So these are the major components in order to drive the processing. So likewise, here in Spark, we don't have any such storage mechanism. From where from where exactly Spark is going to read the data, and after the complete processing, where it is going to write the output data. Okay, so if at all I have the diagram, I will open. Otherwise, I will draw. Hmm. Yeah. So look at here, sir. When it is coming to Spark, from where it is going to read the input data, either it might be a local file system, no problem. Relational database management system like Oracle database, SQL Server, MySQL, whatever it might be. Hadoop distributed file system, or from a cloud vendor, I mean AWS or Azure or whatever it might be. From the cloud space also, we can read the data very well. No SQL DBs, either Cassandra DB, HBase, MongoDB, something like. And at the time of writing the output also, all these particular systems, it can use very well. So it's a very, very important point. Like Hadoop, Spark does not have any proprietary storage system, a predefined storage system. Spark at least will not even support the storage as well. So it is quite open to read the data from any kind of these source systems. And after the processing, the final output, it's going to keep it in any kind of the output systems as well. But within the processing, Spark is having the capabilities how to manage the data within in-memory, within the processing, how to keep the data within in memory, and how to read the data from the cache only, how to apply the processing, and finally, in a very, very quick span of time, after the processing is completed, where it has to store the output data. All these systems it can use. Okay, yeah, please take a snap, sir. So just an example only I mentioned AWS. It can also read the data from Azure or Google Cloud Platform, GCP, all the provisions we have in Spark. Okay, yeah. Next. Very good. So Spark is a in-memory cluster computing framework which is only meant for big data processing alone. Spark does not have any proprietary storage engine, like in case Hadoop is having HDFS. Likewise here, we don't have anything as such. So till this point, are you clear, sir? Till this point, are you clear?
Yes, sir.
Yeah. Now, so, sir, if at all you have to process the data in our MapReduce, what type of the data MapReduce can understand? Can any one of you please? What type of the data MapReduce can understand? If at all I have to drive the MapReduce processing. Okay, no problem. So MapReduce can only understand key comma value record architecture. Value record architecture. MapReduce can only understand key comma value record architecture. In the similar way, what exactly Spark is going to understand? If you wanted to do the Spark processing, what type of the data that Spark is going to understand? Okay, so that is what RDD culture. Okay, even before going to the okay, Spark can only understand RDD type of architecture. But what type of the internal architecture, the understandable format is RDD type of the data. But internally, Spark also, Hadoop is following the master slave architecture. In the similar way, even Spark also following Spark architecture. So Spark internally following master slave architecture.
What is RDD, sir?
RDD I will come back, sir. Resilient distributed data set. So that's a bigger topic that we will discuss. But to work on this RDDs also, who are the players that have been involved in the Spark architecture? So that is where I have started with Spark architecture only directly. Okay, yeah, Spark internally following the master slave architecture. So quickly, there is some architecture document we have, Spark architecture. Okay, one minute.
Architecture flow.
Where, sir?
Architecture flow we have in the previous one step back, I think.
This is only the document, no?
Yes,
Yeah. So you please take a snapshot. This is the Spark architecture here. Spark is also following the master slave architecture only. So it is going to be the master node and these are all the worker nodes. I will explain each and every point here. Please take a snap. So quickly, if I go back to this particular, yeah, so this is what the Hadoop master node, name node, and these are all the different worker nodes, the Hadoop architecture. Name node is meant for only the storage part of the data, and sorry, metadata storage, and the data node is meant for actual data storage, something like this is what the Hadoop architecture. And in order to process the data exclusively, resource manager. So here resource manager is meant for, let us say there are 4 slave nodes. Which slave node is free at this point of time and which is occupied? To get that information only, resource manager is being meant for. For example, out of these 4 node managers, one is busy completely. This has been completely busy. These 3 are free. These 3 are free. So that information only resource manager will in turn provide it to application master. Node 1, 2, and 4. All are been, 1, 2, 1, 2, and 4. These are been meant for. So here, if that is the case, now application master will assign the task on the same 4 particular nodes only, and it will get the response from there. So that's what is happening here. Application master will assign the task on the 4 nodes, and it will get the response from there. So that is what is happening. Okay, and once the request has been assigned by the application master, who is going to execute the same task? Node manager. On a slave node level, each and every node manager is responsible for execution of the same task. On a master node level, these are the things. So this is what we can call yarn architecture at another resource negotiator. That is what we will call yarn architecture.
Sir, one question. Sir, in this case, now node 1 to 4 are free, right? So once the task assigned to these,
yeah, free, correct.
Yes, yes. Once the task got assigned to all nodes, so another task will come and it will wait in the application master, right? Waiting for the resource, like which node it has.
All the nodes are busily engaged with the task. If any new task has been coming, that will be put it on the queue for the next turn. Okay. Yeah. So now here, this is the yarn architecture, sir. In the similar lines, now it is coming to Hadoop, Spark architecture. In Spark also there is a master node. So on the master node only we have a driver program. Sir, this driver program is nothing but the entry point. For example, for our apartment or for our flat, how exactly the main door will be there, the entry point. For our entire Spark execution also, what is entry point? Driver program is the entry point. Within the driver program, Spark context is the actual technical class. Okay, so people who are all from the Hadoop background, who knows MapReduce a bit. So there also we have a concept called driver program. But everything, how exactly the in the driver program also, what is the very first activity? Job object creation. So job object is the main entry point there. Something like here also, driver program is the main entry point. There the technical class, whatever we are using here is Spark context. So Spark context is the entry point for any Spark program. Very, very important point, sir. Spark context, we will simply call in the programming notation SC, Spark context SC. So that is the main entry point for Spark core processing. Okay, yeah. So once any particular request has been starting, from here only, we have to do some use case. So from here only the processing will start. First of all, to assign the task also, sir, in our particular yarn architecture, we have a node manager and data nodes. Data node is a storage placeholder. On top of that, to work with the tasks, we have a node manager. Let me repeat, data node is a storage kind of the player where the actual data is getting stored. But in order to process the data on the data node, there is one more other node called node manager. It is meant for storage. It is meant for processing. Okay. In the similar lines, when it is coming over here, Worker node is very much equivalent to data node. Sir, in Hadoop, in Spark. Here name node, we are saying master node here, Spark master node. Comparison only I'm writing. Here data node I'm writing. Here I can say worker node. Here node manager. Here executor. Okay, something like these are the terminologies. So there it is resource manager. Here it is cluster manager. Not exactly, kind of. A kind of. Okay, yeah. Now, so here there is a Spark architecture. Yes. So here, first of all, it will it has to know which particular executor on that particular worker node. Worker node is nothing but where exactly the data is being present. That is nothing but the worker node. In our Spark language, we will not call it as data node. Rather, it is a very generic terminology, worker node, where exactly the actual work will take place. Either it can be a local file system or Hadoop file system or a relational database table, whatever it might be. Here also, whatever it might be. So what is the exact daemon that is responsible for executing the tasks? So that is nothing but executor. This is only responsible for executing the tasks. So first of all, our master node should know which are all the executors free at that point of time to allocate a job, to allocate a task. So it doesn't know. Spark master node doesn't know. So first of all, in turn, Spark master node is requesting the cluster manager. Can you please provide me all the available executors to assign the task? Cluster manager in turn runs through all these particular executors which is free and which is occupied at that point of time. Spark master node will request the Spark cluster manager to provide the available executors at that point of time. Cluster manager will run through all the available executors and it will provide the same information. Out of 10, only 2 or 3 only available at this moment, for example. There ends the job of cluster manager. Now we got, for example, master node got executor 1, executor 2, executor 9 only free at that point of time. It will directly assign the task on the 1, on the 2, on the 9 directly. Now the relevance, there is no need of cluster manager at this point of time. So that is what is happening. Okay, yeah. So likewise, cluster manager will only work at a runtime to facilitate or to provide the available executors to work on to assign the task. Yeah, fine. So if that is the case, executor is exactly responsible for executing the task that is assigned by the master node. And here by default 2 tasks will be used in our Hadoop also. By default there will be 2 child node manager, child tasks will be there. Here also by default there will be 2 child tasks we are having. Either you can decrease this one or increase also, but by default only 2 tasks will be there. Either you can decrease or increase. So the major difference is, look at here. Whenever node manager is done with its execution, 1 minute, sir, 1 minute, 1 minute. Yeah, whenever node manager is done with its execution, okay, what it is doing, node manager is going to keep the entire output data on HDFS only, either the mapper output data, it's intermediate output data, or sort and shuffle data, or final reducer output data. Everything it is going to store it on HDFS only, because other than HDFS, Hadoop doesn't know anything else in order to keep the data. So HDFS only predominantly they are using. I'm saying within the YARN architecture, node manager is only making use of HDFS only to store our data. But coming back to Spark, okay, coming back to Spark, these executors are going to store all the intermediate results and all within the cache only. That is a major difference here. Their HDFS, here it is the cache. That capabilities have been there in the Spark architecture. Once executors are done with the done with the particular task, they will send the response back to the master node only finally. And one more important point, in our particular Hadoop side, there is a mapper task and there is a reducer task. There are 2 tasks majorly. Internally there will be a sort and shuffle phase, very similar to this one. When it is coming to Spark, here we will call transformation RDD. So what is RDD? I will explain now immediately after the architecture. Just wait. And here action RDD. So here map, in place of mapper only we will have the transformation. In place of reducer only we will have the actions here. So these are the 2 particular tasks what we are going to do within our Spark core processing or Spark processing, transformations and actions. Okay, yeah. So once any particular task has been assigned by the means of transformations or actions, they will complete it, they will respond back to the master node. So that is what is happening in the Spark architecture. So Spark master node will be there. There the entry point would be the driver program. The main technical class over there is Spark context. And in our Spark, the slave nodes only we will call it as worker node. And what is the particular daemon that is responsible to work on the actual task executor? It is just like our node manager only. Yeah, fine. So look at here, sir. Spark uses the master slave architecture. In the above architecture, in the above diagram, it has one central coordinator driver that communicates with many distributed worker nodes. Okay, something like what is the driver, what is the executor, everything I have given. But this is what the control flow, execution flow. You look at here, sir. All the steps I have given very clearly. Till now, whatever I have explained. When you submit an application to the cluster with the Spark submit command, in a Spark clustered environment, we will use this command. How exactly in our Hadoop we will use yarn space jar, something like in our Spark, we are going to use Spark-submit. Yeah, a standalone application starts and instantiate the Spark context object SC. The driver program asks for the resources to a cluster manager. The driver program will ask for who are the available executors now to run my task, and all. They will request the resources to launch the executor. The cluster manager will launch the executors at that point of time who are available. The driver process runs through the application depending on the actions and transformations, whatever the tasks that we have. It will assign the task to the send the task to the executors. The executors run the task and save the results. So this is how the failover mechanism that we will discuss later. So these are the complete steps what is going to happen in the Spark architecture. You please just take a snapshot, all of you, all the 7 steps. But important
Sir,
points.
we will,
Architecture is important.
sir, we will get this document over the email.
Yeah, sure. Okay, yeah, fine. So this is what the Spark architecture. One more time, sir. Within our Spark, we will have driver program, Spark context, worker nodes, executors. So these are the players what we are using. If at all you need a comparison also, you please take down these points. Okay. Yes, we have discussed about the Spark architecture. That is great. But here, transformation RDD, action RDD, everywhere else we are using the term RDD only. What do you mean by the term RDD? Yeah, before I'm going to move on to the same. Till now, whatever I have discussed from the last 30 minutes or 33 minutes, is everyone clear?
Sir, one general doubt, sir. So we are using in-memory concept here, right?
Correct.
So if we attempt any reboot of the servers or any particular node, so the memory data will destroy, right? Clear, right? So in
Yes,
such
yes.
case, how? Oh,
1 minute, 1 minute, 1 minute. I'm putting the charge.
okay, sir.
Yeah, so that is what the reason. That is where the reason just now you took one point here. If at all suddenly that particular node is down also. So there is a concept that is a separate point of discussion, sir. If any node crashes, its task will be sent to a different executor to be processed again. So the failover mechanism is provided by default in our Spark. That I will discuss, sir. But for that, you need to understand the RDD concept clearly. So that is where I left this point. Okay.
Okay, sir.
Yeah, now let us move on to RDD concept now. So what do you mean by RDD? First of all, in the interviews also, by default, people will ask this question, by default. So it is not just, people also very well aware what is the full form of RDD? Resilient distributed dataset. Everybody knows about that. Resilient distributed dataset. But what do you mean by that concept of resilient, distributed, and dataset? What are the features of RDD? That is what the expectation from the people, not the full forms. Keep in mind. Okay, so just to provide the clear glimpse only, you just look at here. I have a detailed explanation for that. Yeah. So you please take down, sir, this point. Here, when I say resilient distributed dataset, the full form of RDD is resilient distributed dataset. What do you mean by resilient? Fault tolerant. Just now, somebody is asking a question. If at all the node is crashed, if at all the node is down, how do we make sure that the same data also will be lost? Then what is the meaning of continuous processing? So that is where I'm saying resilient stands for fault tolerant. Meaning if at all any node suddenly crashed out or suddenly down, still we are not going to stop the processing. Still the processing will be carried out. That's what the exact meaning of resilient, fault tolerant. By nature only, Spark is providing the fault tolerance. You need not to do anything. For example, in our Hadoop, how the fault tolerance will happen? Saurabh, can you please explain? Suddenly, during the processing only, one of the node is down. Then what is going to happen? Saurabh, are you there? Okay, no problem. I don't know. So within our Hadoop, there is a concept called replication. So the same copy of the data is getting stored 3 times. So if not first node, immediately the processing will be switched to the second node or third node, whichever is big. So there won't be any kind of the problem over. Sir, 1 minute, sir, I'll be back. sorry. So here by default only the failover mechanism has been provided in the RDDs. Distributed meaning if at all you are taking some 200 GB of the data, 1 terabyte of the data. So by default only RDD is having the facility to work on the distributed copies of the data. Of course, your data might be spread across multiple nodes, but how to work on all the particular copies of the data in a distributed and a parallel manner. So that facility also we are having. Distributed meaning which is spread across. Data set meaning exact our data, collection of some huge amount of the data. That's what exact meaning of RDD, resilient distributed data set. Sir, are you clear now? The exact meaning of RDD? And very importantly, yeah, this is another important point. So how can you define this particular RDD in Spark? Look at here. I will write something here, which are very, very important points. The main entry point for Spark core processing. The first module is Spark core. Spark context. So that is none other than SE. Okay. In the similar lines, the main programming abstraction in Spark core processing is RTD. These two are very, very important points, sir. Okay. Yeah. These two are very, very important points. So that is what exactly I'm showing here. The main programming abstraction Spark provides is a RDD, resilient dataset, which is a collection of elements partitioned across the nodes of the cluster that can be operated in a parallel fashion. So though the data has been spread across in multiple RDDs on different nodes. So here everything in terms of RDDs only we are going to specify. Like in our map reduce, if you want to do the mapper processing, sort and shuffle reducer, it can only understand the key value kind of the data. For example, some people know only Telugu language. So whatever either there, if they want to understand from somebody else, they can only understand Telugu. If they want to respond to somebody else, they can only respond in Telugu only. That is the only language that they know. Likewise, MapReduce knows only key comma value kind of the data, either reading the data, writing. Likewise, Spark only can understand RDD type of the language only. What do you mean by RDD? It is a collection of elements which is partitioned across the nodes of the cluster that can be operated in a parallel fashion. Okay, either you take the input data, input RDD, then transformed RDD, then after converting all the transformations under output action RDD. So everything in terms of RDDs only. Other than RDD, Spark doesn't understand any other language. Okay, next. Like those are all the classes. So whatever you're saying as a classes. Likewise here, we will also introduce those classes and all. We don't have any. In fact, there is no classes as such. Yeah, this is where the important point. Spark, all the work in Spark, how exactly we are going to represent creating the new RDDs. Input RDD we will call. As per our requirement, raw data only we have to convert into the required data, transforming the existing RDDs, calling the operations on the RDDs to compute the results. So these are the three things: input RDD, transformed RDD, action RDD. So these are the three things. Okay, so what are the key features of the RDD? That is the case. Key features of RDD. The very first one is RDDs are by default immutable. So what does it mean? RDDs are by default immutable. So meaning to say, if at all you are opening a particular file, okay, if at all you are opening a particular file, or you are going to apply the logic over there and finally storing the data. So anything by default RDDs are immutable. So they will not be changeable at all. So I will explain one use case now quickly to understand better. Yeah, let us take some Cisco use case only. So Cisco is providing the log data of 1 terabyte. Out of that, there are three requirements we have. We need to get the count of error records. Secondly, count of error records, count of records starting with error. Third one is count of records ending with error. So these are the three requirements. So here, though there are three requirements, all are revolving around the error only. You look at here, error, error, and error. Okay, yeah. So here, as a very first step, yeah. So as a step one, Okay, here we are going to say input RTD. So what does it mean? Input RTD meaning referring or opening the input file or input data. Okay, so this is what, sorry, input, not input RTD. Let us use a proper technical term only, base RTD. Okay, fine. So now step 2. Step 2. So here, transformed RTD. What does it mean? From the raw data, we have to get the required data. So here, what is the, from the raw data only, what kind of the data we are supposed to take it? From the raw data, only we are supposed to take the error based data. Okay, yeah, so that is what the expectation. Now as a step 3. Okay, so this is where transformed as reaction RTD. Reaction RTD. So now applying the computation. Applying the computation on transformed RTD. Okay, yeah, so we are saying, I mean to say, we have to get the count of all the RTDs now. So here, if you look at the first requirement, we need to get the count of the error records only from the below only. So now, if at all the processing is going to start here, at the first RTD level, the processing will never ever start because Spark internally following the bottom to top approach. Always please keep in mind, sir, Spark will always do follow bottom to top approach. Bottom to top approach, meaning in this first step, processing will never ever get started because here all the 1 TB of the data you are reading. Here all the 1 TB of the data you are been scanning or reading. So what should I do with that particular data? We don't know. So processing will not get started here. In the similar lines, at least in the second step. Okay, in the second step also, processing will never ever start because here you are asking convert the raw data into error data. Okay, I'm getting the error data. Compared to your step 1, here it is somewhat better. But what should I do with the error data? Still there is no clarity. Now get the count of the error records. Here what we are doing, count of error records. Count of error records. That's what they are doing. So here, from here only the actual processing is going to start. Okay, so if that is the case, from here to apply the third step. So to get, first of all, I need to get the count of error records. But where I'm getting the error records, then from the step 3 only, it will go to the step 2. Okay, so here, yes, from the raw data only I'm getting the error data. Where is the raw data? From the step 2 to step 1 it will move on. Okay, so here 1 terabyte of the data is there. We are reading the data. First record, there is no error. Okay, so leave it. No. Second record, there is a error. Yes, take it. Third record, there is a error. Take it. Likewise, it will only scan the whole 1 terabyte of the data. You know, out of that, for example, there are 4 lakh records we are having. There are 4 lakh records, error records. So these 4 lakh records, not only in the first use case, second use case, third use case, if at all there is any other continuity, it might be there. So all these 4 lakh error records, it is going to keep it under the cache. Cache or in memory, it has been keeping. Okay, complete in memory, it has been keeping the data. Fine. So from there only, now, yes, we got the same kind of the 4 lakh records only in the cache. So just here, we are for the first requirement, we are going to apply the count on this particular 4 lakh records. So only the input data, though the input data is 1 TB, these 4 lakh records only predominantly used here. Okay, one requirement. Second, count of the records starting with error. So now tell me, do I need to go from the step 3 to 2 to 1 altogether to achieve the second requirement? Anybody? Just think and tell me. In order to drive the second use case, do I need to follow all the 3 steps?
No, yeah.
Yeah, what is your answer?
Directly second step, we will pick the data. Second requirement, third requirement.
So already error based data is readily available in the cache. So why should I go back to the original data again? In those 4 lakh records only, how many of them are exactly starting with error record? For example, for the second record, there might be 1,35,000 records. 1,35,000, lakh records there might be there, which are starting with error. Now third requirement, count of the records which are ending with error. So if that is the case, again the same story. I need not to go back to the 3 to 2 to 1 kind of, only with from step 3 to step 1 only. So because of storing the same data in the cache, So this is what the advantage we are getting. For example, only 65,000 records only, which are exact ending with error keyword. Fine, very good. Now we are completing the use case. Sir, before you are going to start the second record, second case study, there is a change happened. Listen very carefully. There is a change happened in the original data, meaning 10 lakh records. 10 lakh records, I'll give a different color code. Otherwise you may get confused. Yeah, 10 lakh records got removed, deleted, and the additional 10 lakh records are added. Meaning if you look at count wise, input data is same, no difference at all. 10 lakh removed and 10 lakh added. But can you say these two particular results, are they going to be accurate?
In this flow, no. Why? Because we are picking from second step, right?
1 minute, 1 minute. I'm asking all the rest of the people. First of all, have you understood the problem, what I'm trying to say? So please unmute and speak, sir, please.
10 lakh, the data may be different.
Yeah, so we got the before you are going to start the result. Sorry, after doing this is what with the original data. But meanwhile, before you are going to start the second use case and third use case, there is a change happened. 10 lakh records deleted, 10 lakh records added. So, but what is the guarantee? The same number of the 4 lakh error records only we might be having in the deleted error records. Okay, in the deleted data, there are, let us say, 1 lakh error records are there, for example, in the 10 lakh records only. But in the newly added 10 lakh records, there might be 1,80,000 records. So what is the difference then? If at all we are assuming with the same data 1 lakh only, yes, this particular 4 lakh is fine. But 1,80,000 extra records are coming. So the count is also 4,80,000. But we are only considering 4 lakh only. So why this kind of the changes happened? After you capture the error records here, there is a change happened in the original base RDD, raw data. So now whatever the use cases you are applying on the 4 lakh records, all of them are wrong only because our original data is changed. Now it is a new data completely. So that is where to avoid these inconsistencies only, what they have defined, once you start with the processing, keep a log. Once you start the processing, it is not supposed to be change the data. If at all the data, original data is changed, it is a new RDD only, a new job only. But within the same RDD, if at all we started the job, it is not to allow to change the data once it has been started. It should be a lock only. So that is what I'm going to say, immutable kind of the nature. One RDDs are immutable only, we are going to achieve all these results. If at all this data is keep on changing, these results also inaccurate. So that is why RDDs must be of immutable nature. Is everybody understood this problem? Sorry, this feature? Or any questions?
Clear.
Yeah, fine. Yeah, very good. So RDDs must be of immutable nature. So next one.
Sir, my side to understand one thing. Yes. In this concept, we are using bottom to top and scanning the records, right? So top to bottom also, we have to scan 1 terabyte data, right? In same scenario, but keeping in the cache memory is the concept, right? Is my understanding correct?
No, sir. Bottom to top is nothing but how the processing will happen. It's not in the way of scanning the data, how you are scanning the data. Is it top to bottom or bottom to top? Not in that sense. If there are 3 RDDs are being provided, yes, RDD, transformed RDD, action RDD. Spark processing will always get started with the action RDD only, but not with the base and transformed RDD. So that's the same flow I have explained here.
So in any case, we have to scan all the records, right?
Yeah, sir, if at all there is some particular 10 lakh records customer is giving, without scanning the data and all, how do you say these are only the error records? And here, for example, there are 100 employees going to one interview. You have to only pick the people who all came for Hadoop and Spark interviews. Without going through all their 100 profiles, how do you say how many of them are Spark profile, Hadoop and Spark profiles there? Are you getting my point?
Yes, sir.
Yeah.
So here the thing is, from bottom to top, we are knowing the requirement, what we are going to do.
Exactly. So meaning, even though the first step you are providing, immediately processing will not get started here because it's useless. I don't know the requirement very clearly. Here you have written some transformations, meaning from the raw data, I am only expecting here in the raw data, there might be log records, debug records, warning records, info records, error records. But based on my use case, what is the data that I'm expecting? If at all you have to get all the error-based data only, if I'm filtering the debug related records or warning related records, it's of no use. I have to get only the required data, meaning out of the 1 terabyte of the raw data, how many error records are there? That data only I have to get it. That's what you are doing in the step 2. In the step 3, yeah. Now here also you are getting the error data, agree. But what should I do with that error data? Still, it is not clear for me. Here you are saying I need the count of error records. Yes, it is exactly the final requirement. Here there is no continuation here. I need the count of error records. There's a lot of clarity here. So by picking up the same, now we are going to, to get the count of the error records. Where exactly we are getting the error records? I'm going to the step 2. To get this error records, where is the raw data? Now, in a reverse engineering manner only, we are doing the processing in our Spark. So if that is the case, only the slim data, required data only we will get it, not all the junk data. Though there is 100 crore records here. But what is the actual data we are considering here? Only this 4 lakh records alone. Only this particular 4 lakh records alone we are been considering. That's it. So here, because the volume of the data is drastically reducing, and that too, this data we are keeping in the cache. That is where Spark is giving 100 times more performance than Hadoop. Okay.
Okay, sir. So in each action RDD, only one action we can perform, one requirement, right?
First of all, we are writing count, one action. Later, if you are writing some other action, accordingly also the same this particular bottom to top only. Any particular action you are writing, from there only the processing will be triggered bottom to top or in a lazily manner. What do you mean by lazy? Okay, I will talk about that next key feature.
Okay, sir. Thank you.
RDDs are partitioned. What do you mean by that? Meaning, if you have to process the same data, let me take the same example. If you have to process this 1 terabyte of the data, if you are keeping all 1 terabyte of the data in one mission only, and you are applying this Spark processing, even though you are following the bottom to top approach or in-memory processing or blah blah, if the data is not partitioned across, distributed across the different nodes, it will take a lot of time. So that's where one of the key feature of RDDs itself is, though your data storage data is being distributed across the multiple nodes, though your data is being distributed across the multiple nodes, also here some data, here some data, 1 minute. Yeah, here some data, here some data, here some data. Spark RDDs are having the capabilities how to apply the processing in that partitioned and distributed manner. That's where RDDs are partitioned. Next, RDDs are catchable. Meaning, if at all you are doing the processing, same use case only, sir. If at all you are getting 4 lakh error records only there, and those 4 lakh error records also I'm going to reuse in my next use case and next use case and next use case. There is a reuse over there. There is a reusability here. So if that is the case, every time why should I go back to the original data and do scan all the data and get the same data here? I am anyways in the first requirement only I'm getting the error based data, so that if I store the same data under cache, I can reuse the same data for the next set of the use cases. So but if at all you want to do the same thing within our Hadoop, there is no such concept of storing the particular intermediate data or something in the cache, because Hadoop knows only one guy, HDFS, whether it is a raw data, intermediate results or final results, whatever it might be. Only you have to store the data under disk only, HDFS only. Whereas in Spark, yes, they have given the provision to store the data under the cache as well, so that RDDs are catchable, meaning we can store the RDDs data in the cache. That's what they mean. Next, RDDs are lazily evaluated entities. What do you mean by the same statement? So RDD processing is always happening in a lazy fashion, meaning, for example, sir, one layman example only I will provide first. What do you mean by lazy? In a particular class, there are 2 students. A student, okay, otherwise, sir, if at all anybody's name is matching, please excuse me, sir. It is only for my, otherwise, person Gopal is there, person Krishna is there. I will take my name, no problem. So there are 2 people. Listen carefully, this layman example. So Gopal is a very, very dedicated person. 1 minute. Yeah, so Gopal is a very, very dedicated person. In his particular BTech semester, if there are first day one topic is completed. One topic is completed. He has prepared the particular topic very well. Okay, but like second day one more topic is happened or one more chapter. So likewise, in his semester altogether there are 350 topics are there altogether, whatever it might be. All the 350 topics he prepared very well. But Krishna is a very, very lazy guy. Like whenever the examination is there, then only he will react. But he will not even go through all the things and all. So next 1 week only we have the semester exams. Then he started with the topics. So 350 topics or 350 particular topics preparing and all within 1 week, it's not viable. So he's preparing the test papers or whatever it might be. He only took maximum 20 questions. That's what he mugged up like anything. Only the 20 questions only he took it from all the test papers, frequently asked questions and all. Now both of them approached the exam. Luckily, whatever the 20 questions Krishna has prepared, 12 questions came. Okay, all the 12 questions are in the examination only. Totally there are 15 questions we are having. You know, so out of that 12 questions are whatever he marked up. So end of the day, Gopal is getting 74% of the score, for example, and Krishna is getting 81% of the score. So what might be the reason, sir? Let us speak technically. What might be the reason?
It is just luck, we can say.
It's not luck, sir. No, that's where I mentioned very clearly. Speak technically.
The probability Krishna calculated is went well. Like it's worth 90%. The probability.
No, let me provide, no problem. So my point is
That
he
important
has
question.
prepared 350 topics, right? He has prepared all the 350 topics, and from there, out of these 350 topics only, he has to take out the results, take out the answers of these 15 questions. So his presentation may or may not be correct. Huge volume of the data is there in his mind. Out of that, he has to present these 15 answers. Okay, but if you look at Krishna's case, in his whole mind also 20 answers only there, 20 questions and answers only there. Out of that, he just presented these 12 questions. Okay, so which is easy, sir? Out of 350 versus 12 or 20 versus 12? It's a very generic question.
20 versus 12.
21.
20 versus 12.
Because the volume of the data is very less, so that's where the presentation is also very nice. That's where he got more score, and he has how exactly he has prepared from the day one. Yes, he prepared, day two prepared. So top to bottom is coming, Gopal. But how exactly Krishna's preparation? Now the examination data also came from the in the reverse way. How he is not prepared all the chapters and all. So whichever are important, he picked up the questions. Those questions only prepared. So I mean to say bottom to top. Okay, his approach is bottom to top. So his preparation is very lazy. Once all the particular topics are ready, out of all the topics only which is very important, refined way only, he prepared over. So that's where his particular, the presentation and everything is very faster, and he got some 81% of the score. I don't know whether you understood this example clearly or not, but very apt example. Okay, he's preparing, he's doing the things in a very lazy manner, but still he's only getting the required data only, and on top of that he's applying his thought process. Okay, yeah, so Spark also following that lazy evaluation only. In our example, very good, Saurabh. Gopal is Hadoop and Spark, Krishna is Spark. That is what our exact final takeaway. Because Hadoop will always process the data in a top to bottom manner, whereas Spark will always do the processing in a bottom to top fashion. Okay, understood, sir? This example at least some way.
Yes, sir. Makes sense.
Yeah, fine. So these are the very important key features of RDDs. Whenever we are doing the processing, also you should know about this one. And any questions till this part? Okay. Next, RDD operations. The very first one is transformations or transformed RDD. Second one is actions or action RDD. Transformations are transformed RDD. Actions are action RDD. Okay, yeah. So what exactly you mean by this transformation and all? Sir, this is also you have to try to understand. Okay, I will write it here first of all. Converting the raw data into required format. Okay. Transformation result is always a RDD only. So they cannot return any value to the driver program. You will slowly understand these points. And examples of transformations: map, filter, flat map, group by key, reduce by key, sort by, etc. So these are all the different examples of transformations or transformed RDDs. Okay, now coming back to action RDDs. To apply the computations on RDDs. The action result is always a value to the driver program. They will not produce one more RDD. Collect, count, take, top, save as text file, etc. So these are all different actions. Okay, so transformations and actions. So if you look at, there will be a source RDD. Let me save this one, so it is very much required. Source RDD, destination RDD, target sources. target RTD. Source RTD, a value to the driver program. Source RTD, target RTD, source RTD. Now from there, the result is always going to be a value to the driver program only. This is transformations. These are actions. Okay, yeah. Yeah, please take it. Okay, next. Okay, you will understand these things once we install Spark, and when we are going to see the result, then we will see all the things. So now I will show you the installation procedure, how exactly we are supposed to do. So to install Spark, first you can go to the this kind of Spark archives. Yeah. So the very first link only the Spark archives we are getting. So whichever the version you are going to install here, you can pick it up the same. So now I'm going to use Spark 2.1.1. Any other version also you can use, nothing wrong. But whichever is popularly using in the real world, that version only I'm using here. So I will go back here, and if you closely observe, sir, you look at here, Spark, plain Spark related jar bars are only few, but remaining all with Hadoop. How many are there with Hadoop? You look at here, almost. Without Hadoop only 3 or 4, but with Hadoop almost. So the reason here is, in our real world also, on top of the Hadoop clusters only, we are making use of Spark, meaning storage is going to be under HDFS, but Spark is going to be through Spark. Sorry, processing is happening through Spark. So that's what is happening. So with respect to Hadoop only, we are supposed to, it is better to practice the things as well. Here I'm going to our Hadoop version here. What exactly the Hadoop version? So 1 minute, let me reboot the mission. Let me get into the other image.
I just want to inform the installation of VMware and the setup we have not yet done.
Not
So
yet done,
yesterday we
meaning?
got stuck.
I'm not getting.
No, yesterday we got stuck, right? Like the installation of the VMware and the Scala.
No, whenever you people are ready, I'm ready to shoot any point of time now also. But the thing is, you have to download those files, extract those files in your local system. Is anybody ready now?
Yes, I'm ready, sir. We'll do at the end of the class if you're okay. Or now
No,
also
no.
fine.
Let me
I don't
provide.
want to.
Before giving this one only, let me provide. I will give you the share. Can you open, sir? Can you show all the files? Can I provide a screen share? I mean, can I make you the presenter so that you
Yes,
can
yes,
share your
yes,
screen?
sir.
Yeah. I made you the presenter. Can you please share?
Yes, sir. Please continue.
So first you show me all the files, whatever they have given and whichever extracted. That one you already extracted, right? Scala tarball also.
No extract I can see, sir. Zip only open.
So you need to have the WinRAR in your particular system. Then only you can. So anyone else is ready? So you know, if anybody is ready, I will show that one, sir. Otherwise, how can I show that one?
Sir, I'm not aware extracting this rare one. Give me a few minutes. Like by end of the class, I will be ready with all the things.
Okay, that's fine. From your side, it's okay. Rest all, are you not even opening the images? Are you not able to even start the practicals also? You don't want to?
Gopal Ramesh here. I think I could able to download and able to log in into the image and able to test the scale up.
Okay, okay. So is everything is working?
Yes, for me everything is working. I could able to run Scala in the command prompt.
Okay, then only the problem is from your side, Satish.
Sir, I will have it try, sir, by going through the documents. If anything, then I will send an email. Is that okay?
No, can you share your screen again? I will give the screen sharing again. So what you need to do, I will tell you.
Okay,
You
sir.
just you please share your screen again.
I did not get the share option.
No, you are only the presenter, sir, I think. Yeah, first
Okay,
step. Yeah, I got the screen. Yeah. First step is you are supposed to install the VM workstation. Go back to the VM workstation. Yeah, so first is the last one. Yeah, double click on that. It's self-explanatory.
also meanwhile I will extract these.
Okay. Extract to Spark and Scala. Right. So let it be, but meanwhile you start with this VMware workstation. You minimize this window, sir. Yeah, so VMware workstation has also been started. Yeah, so click on next, accept the agreement, next. No, leave it. Yeah, next. Yeah, next. Desktop also you have the icon, startup menu, say next. Install.
And
Yes. Install. That's it.
so no need to set up the RAM size are here, the VMware workstation.
One by one. First VMware workstation has to be installed. At the time of browsing the image only, you have to do all the things. I'll tell you one by one everything. So if anybody else is also having the same problem, please concentrate here, sir. So it may take a couple of more minutes. Please bear with me so that we can finish up this one and we can move on with Spark installation. What is the RAM speed in your machine?
16 GB.
Yeah. So click on finish. Yeah, fine. So now you open on the desktop also you have the VMware workstation, right? You open that one. Double click. What is the problem? Close. Compatible assistant. You please reopen. The app can't run because it causes a security or performance issues on Windows. What is your processor? Is it what is a Windows? Sorry, Intel Core Processor 11.
Yeah, like i5 sir I'm using.
So it is not a problem with respect to this VMware workstation, sir. In your system only there might be some kind of issues with the security feature and all. So that's where I'm asking. If at all it is a Windows 11 or processor, Intel processor, i8 version also if you are using, then we will log in. But there itself, VMX related issues you will get it. So please look at this error once VMware workstation is installed. So what are the next step? I will quickly show you. Let me take the control.
Sir, what is this version of you provided, sir? VMware? Is there any upgraded version?
No, that the new versions and all you have to download from the internet only and you have to use it, sir. If at all
Will that work, right?
Sorry?
Will that work or only these versions will work?
No, it will work. But here the VMware key, whatever we have given is only for VM workstation 15 only. But I have the license key of 16 as well. But the thing is, you have to download from internet. VMware workstation.
Okay, sir. Then I will have a look into this, sir.
Yeah, so once it has been completed, okay, what you need to do once the VMware workstation is installed. In my case, also the same image we are getting. Look at here, VM workstation. Once you open, the look and feel will be something like this. You can click on open a virtual machine. You have installed Spark and Scala image, right? Already, you have extracted. Go to that particular folder, and then you have to just browse this particular plain image only, VMX image only with the 3 square symbols. You can just browse that image and click on open. Once you open the image, there it will ask what is the memory, what is this particular, rest of the other things and all. It will ask you here only. You will see this page. So if you want to change the memory here only, you can click on memory and you have to change the memory also here only. What is the speed that you want to set? Either 4 GB or 8 GB, whatever it is, you can set this one. And post that, you can click on power on this virtual machine. That's it. Nothing more. Okay.
Okay, sir.
Yeah. So let me log into the VMware cluster and here. Yeah. So this is the one I'm going to download now. So this is one approach. And second approach would be official Spark downloads page. You can go ahead. Either this way also you can go. This is the official website also. So here also you can just come down here. You will see all the release notes and all archived releases. You can go to Spark release archives. Archived releases. You are getting here. Spark archived releases. You can go. And here also, whichever the version you are going to download, that also you can download here. So any of the way. So this is the version what we are going to download. And I'm using the Hadoop version of 2.6.0. I will show you what is the version of Hadoop I'm using here. Sir, without Hadoop also you can install, no issue. But industry practice would be while reading the data from Hadoop only, you are going to work with the Spark. So that's where I'm showing with Hadoop only. Hadoop space version. What is the Hadoop version I'm using in this system? Yeah, you look at here Hadoop 2.6.0. So that is why I am also going to download that respective. So that respective Spark tarball file only. So here 2.4. This is the 2.6. So the moment you click on Spark-2.1.1-bin Hadoop 2.6.tgz. What is tgz? Tgz full form is, okay, otherwise I will write it here. Yeah, so it is something like tgz meaning tar.gz. That one only they have mentioned as .tgz. So this extension is nothing but same thing. So in order to extract this particular, just now he has extracted the files. He right click on the same file folder and he extracted the files. But in Linux, if you want to extract a tarball file, the command would be tar space -xzbf followed by this particular file. Here -x stands for extract, z stands for zip file, v stands for verbose. Verbose meaning in a detailed manner. F meaning file format. So extract the zip file in a verbose file format. That's what the exact meaning here. Okay, -xzbf. Okay, yeah. So now here I'm going to download this one. The moment you click on the same, the download process also getting started here. You look at here. Yeah, you download process also been started here. And you can see the download process also here. Within few seconds, it will get extracted only here. But one important point, sir, the moment you click on download, it is not asking for your credit card number or debit card number. Meaning to say, Spark is completely an open source framework. There is not even 1 rupee of the cost is associated here. It is completely free of cost. So that's a clear evidence. And the download process also been almost completed. Okay, now if you wanted to copy this particular tarball file, copy the tarball file from Windows, keep it under the install directory in our Ubuntu system. But here what I'm doing, sir, you please create to install on your own. It's already been installed, sir. In the given Spark and Scala image, it's already been there. Okay, but if you
sir, we are downloading inside the VMware or local machine, sir?
No, I'm downloading within the Ubuntu system only, and from here I'm transferring the tarball file. Or if you want to download directly here by opening a browser, that is also fine. So you can open a browser, you can do something here. From this download folders only, you can shift the file to install directory. That is also fine. But in the given Spark and Scala image, Spark is already installed. You need not to do anything. Got my point? So here also Spark, Apache Spark downloads. So here also you can do the same thing. So directly security or something, I don't know. Like there might be some kind of restrictions here. So sorry, you can download the files from here as well. And once it has been downloaded, it will be part of your downloads folder only. From there, you can take it to Spark archives. Yeah, so here only you can do these things, no problem. Yeah, so this is where once you download the files, it will go to the downloads folder here. So from there, you can copy the files to the install directory. So that part also you can do, no issues. Here it will come in the download. Okay, now, so in my install directory only, first you have to create, sir. If at all, sir, install directory is not appearing in my case, if that is the case, what you can do, mkdir install. Okay, so go inside the install and keep it here. Inside the same, you can keep this particular Spark tarball file. Yeah, so the same thing I am already having it. So now the same thing, what you are supposed to do, xzvf followed by, this is what the command you have to execute. So once you execute the same command, we are getting, sir, you look at here, all of you. Once you extract the tarball file in Linux, how can I say it is a file only? The starting letter is hyphen, meaning it's a file. So once you extracted the same Spark tarball file, we are getting this Spark directory. The starting letter is D, meaning directory. So once you go inside the Spark directory, here you will have bin directory, conf directory, yes, bin directory, and something. All the way we are having. Okay, so here, once I go inside the bin directory, yeah, so here multiple other commands we are having. So what about these commands and also I will mention one thing, sir. In the Spark architecture only, I mentioned one thing, there is a cluster manager. Can anyone provide me, sir, can anyone explain what is the main purpose of cluster manager here? What exactly it is doing?
It is giving the available nodes to the
exactly. It is providing
driver.
the executor information to the Spark driver program or Spark master node. Very good. But in reality, there will be 3 cluster managers we are having. Okay, there are 3 type of the cluster managers we are having. Yeah, so you please just take a snap, sir. Different cluster managers in Spark architecture. Standalone cluster manager, which is default one, Hadoop Yarn cluster manager, and Apache Mesos. Here in our particular course, the first 2 only we are going to cover. Apache Mesos, it is altogether a separate entity. No, generally in real world also 1 or 2% only Mesos will be used. 98 to 99%, this Hadoop Yarn only the most important one. Okay, yeah. So these are the 3 categories. What do you mean by the same? When I say standalone cluster manager in a single mission only, how do you connect it to the prompt? Either Scala prompt or Python prompt or R prompt or whatever it is, and how do you drive the processing? That is what standalone cluster manager. Hadoop Yarn meaning in a production environment, in a batch mode. If you wanted to do the Spark processing, how can you do that one? So that's what the difference. It is from the single node perspective, one mission only. It is from the batch mode perspective. These are the 2 cluster managers. Okay, so now to drive the Spark processing in standalone cluster manager mode, okay, using Scala. What is the command we are going to use? Spark-shell. Using Python. What is the command we are going to use? PySpark. Using R language. Spark R. Using Java. No support. Meaning in a standalone cluster manager mode, we cannot get into the Java prompt or something and we can't drive this one. It is only available in the batch mode only completely. So these are the commands. Spark-shell, PySpark, Spark R, where all these executables are available in the bin directory. You look at here, sir, PySpark. If you wanted to use Python to drive the processing, Spark-shell to use Scala, Spark R to use R language, something like so. Every time I cannot come down to this bin directory and all. If I know the path, I will come down. So like in Java, how exactly we are adding the path variable and Java home variable to the environmental variables. Here also there is one particular path. I'm taking this entire path. Here in our Linux platform also there is a file called bash.rc. How do you open that file? Nano tilde operator. The starting is tilde /bash.rc. So very important point. All the global paths, global variables should be part of this particular bash.rc. What is the importance of this bash.rc file? Along with the operating system, the first configuration file what is getting loaded is nothing but bash.rc. That is why all the home paths, meaning here only we have to add. So when I open bash.rc file, so here you will see, look at here, Spark home. Where is it? Yeah, Spark home I'm adding over here only. So otherwise I will give. Yes, so I will, this is a commented line. Let me remove this one. Yeah, export Spark_home is equals to, on the right hand side, same path where exactly our Spark has been installed, we mentioned here. Okay, so cd install, here cd Spark, here only all our particular directories have been part of, bin directory, everything. So this is where the same path I mentioned, here only Spark has been installed. Home Gopalkrishna install Spark 2.1.1 something. Export path is equals to the global path variable only $spark home. So when I say Spark home is equals to something, when I say $spark home at runtime, whatever is there after is equals to symbol, that will get substituted here. When I say $spark home, what is the value here in the above line? this particular path. Inside that there is a bin directory. So that bin directory, Spark bin directory only, we have been adding it to the global path variable. So in that regard, what is the beauty here? In any path, if you can simply type the command, if you can simply type the command of any of these commands, you can type in any of the path. Yes, we will get logged into the same thing. Otherwise, if you not add it to the bash rc file, it will say undefined command. I don't know what is this command you're saying and all. You have to add it to the global path variable only. Okay, yeah. So that is what the Hadoop installation, sir. Sir, 1 minute I will. You need not to start this Hadoop daemons, but in my cluster, as a Spark integration with Hive is already in place. So at least for that Hive purpose, I need to start the Hadoop daemons. So only in my case, let me start with the Hadoop daemons. But you can directly trigger the command spark-shell, no problem.
So, sir, the tar file was given to us. So that is contained with the Scala and Spark, all the software, right? No need to install again Scala, Spark one, or we have to install as you said this.
1 minute. Saurabh, are you there in front of the laptop? If I can give you the screen share, can you show
Yes,
that
sir.
one? Yeah. So quickly for answering his question, I'm giving one thing. Saurabh, where he is. Not able to see your name. 1 minute, sir. Below it is there. Yeah, I made you the presenter. Can you please share your screen quickly, Saurabh? Yeah. So now, can you get logged into the VM workstation? Have you browsed the Spark and Scala image? Not this Hadoop 2.xml, sir. Spark and Scala image. Okay. Have you at least extracted? I will tell you.
Sorry, sir, I haven't.
Have you downloaded the Spark and Scala folder at least to your local?
Yes, sir. I have actually connected with my office system, and the installation all I'm doing on my local personal laptop, so I cannot share the screen. I have that extracted file. There is, I can see the 3 squares image, plain image. So that contain all the Scala and Spark.
Yeah. So I think is anyone else, sir, who can share the screen and show? Because once we log into the Spark and Scala image, it's already there. Everything is there. Just I wanted to show that one from your systems only. Ramesh, can you? Is it possible to share the screen?
No, sorry, Gopal. I logged in from phone actually. I'm not on my laptop at all.
Okay. No problem. Okay, so yeah, so once you log into your Spark and Scala image, and you can just drive these commands, you will get the things very well. So just I'm saying here, my daemons have been running here. So yeah, whether running or not, it really doesn't matter for you. So you can directly execute the command what I'm showing here. Yeah. So just you can type the command spark-shell from any path. From any path, you can just type the command spark-shell, so that what exactly I have written here in a standalone cluster manager mode, you can drive the Spark processing. That is what the intent of this command, spark-shell.
Okay, sir. Okay.
Sir, one question: the files we have in the local system, right? Will that copy into the VMware directly? Copy paste?
Which file, sir? I didn't understand.
The local machine, we have the files you shared via email, right?
Okay, so you can just copy a file and put it in the you can copy the files from the Windows file structure. Yeah,
Paste
so
in the
here
VMware.
you can just copy this file, right click and say copy, go to your operating system, wherever you want, you can just paste it.
Okay, it is working. Thanks.
Yeah, now you look at here, sir. Spark context available as SC. You need not to do anything. By default only, Spark is providing this object SC. Okay. Now successfully, I'm getting into the Scala prompt only here. My Spark version is Spark 2.1.1. So is it successfully are we getting or not? I just triggered the command spark-shell. I'm getting into the Scala prompt only. In the next one, another shell I will take it, and what I will do there, I will do PySpark. I will use the command PySpark. Meaning, if here in this regard, you can drive the Spark Python language. Now you will get logged into the Python prompt, meaning 3 greater than symbols.
So here we are getting Scala prompt, right? We can practice Scala as well, direct, right?
No. That is a wrong perception. Here, it will only to understand the Spark API classes only, not the normal Scala. So that's where, if you want to drive the Scala use cases, only you can go ahead with the Scala only. Okay. Here, Spark you are getting and 3 greater than symbols. This is the Python prompt. So if you want to drive the Spark Python processing, you can make use of this particular command. So now perfectly what I'm trying to say, our Spark is successfully installed. That's what I'm saying. Is everyone clear, sir? the installation procedure of Spark?
Yes,
Please
sir.
respond.
Yes, sir.
So, but if at all you have to come out of this particular Scala prompt, you have to use same notation colon Q. Okay, so that's one thing. And from the Python prompt, if you want to come out, Control D, you will come out. That's it. From Python prompt, Control D. From the Scala prompt, colon Q. Okay, again I'm logging, sir. Now we will start with our first use case now. Yeah, so anyway, it's been close to 2 hours I have started the session. So we'll take a 10 to 12 minutes break now, and then we'll continue with our use cases. Will it be fine?
Yes, sir.
Yes, sir.
Yes, sir.
I'll be on mute, sir. Yeah. At the rate 1, 2, 3. Yes, sir. Is everyone back?
Yes, sir. And I have completed the installation. And can I share my screen, sir?
Ritvik. Yeah, if you have installed the, yeah, so I will give you the screen with it. Yeah, I'm making you the presentation. Yeah, login.
Sir, what is the password, sir?
Gopal at the rate 1, 2, 3. Sir, otherwise what I okay, anyway logged in. Go to the
Yes,
terminal. You can maximize the window. From the right hand side, second icon. Above. On the right hand side, second icon.
1 second, sir.
Here also you can maximize the terminal. Yes. Yes. Increase the font a bit. Control Shift plus.
It's not working, sir.
By holding on a control and
Yes, sir. I'm doing the same.
No.
It's working.
Yeah, now type the command spark
Sir, Spark
-shell.
shell. Okay.
Yeah, enter.
So, sir, once you set the environment, we can type Spark shell.
I'm
Then
getting the echo from somebody, sir. Can you please go on mute? Others? I think Ritvik, it's you.
sir, in the VMware, post configuring the bash file, if you type Spark shell, then it is expected output, sir.
No, bash RC file has to be added to the, your Spark home path has to be bash RC file. Then only from any path you can access this particular Spark-shell.
Okay. So in my case, once I got installed VMware, then I can go ahead and configure the bash file and run this Spark shell, right?
You need not to configure any bash RC something. It's already there, everything. You just like the way what Ritvik is doing, you have to do the same thing. Type the command Spark-shell. Yeah, perfectly you are getting into the Scala prompt. So say colon Q. No, colon Q.
Sir, your voice is a little muffled, sir.
Colon Q. You just type colon Q and enter. Sir, am I audible?
Yes, sir. We are able to hear it. We are able to hear it.
Control
Yes,
L.
sir.
Control L to clear the screen. Now type the command PySpark, py spark. Enter. Yeah, perfectly. You're getting the Python prompt as well. 3 greater than symbols. Say Control D, you will come out. Yeah, sir, you place the cursor. Ritvik, you place the cursor on the left-hand side. Launch editor only. We will have IJ, IntelliJ IDEA, IJ. Yeah, it is one of the editor we will use for our Spark use cases going forward. And to drive the Python related use cases, we have PC, PyCharm community. PC, yeah, PyCharm community. So all these IDs we have given within this particular installable only, and you can go to the install directory, sir. Ritvik, go to install directory. Click on Eclipse. No need to start. Yeah, Eclipse. Yeah, the icon, diamond icon. You can double click on the diamond icon. Yes, Eclipse Oxygen, whatever I have shown yesterday, that will get open now. So everything has been already installed. That's what my point. You need to just go and operate.
Okay, sir, how do I switch from one window to other in Linux, sir?
You can go back to the.
I mean, in Windows we can use Windows tab something like that, right? Is there any toggle something like that?
Go to your terminal.
Okay.
So to open a new tab, you can press on Control Shift T. Control Shift T. One more is open. So something like.
Okay.
Yeah, that's all, sir. So that's what I'm saying. It is already been there. Everything is there. Only the thing is you have to plug and play. Okay. So now I'm relogging. Yeah. So we will start with the first use case. All of you please look at here. Here in this window, there is a path called path spark. So this is what the path. Here I have a file called input.log file. Okay. So now when I open the file, input.log file, here this is what the data what we have. So now I would like to know how many lines of the data and what is the length of that particular line. So that is what we are supposed to get it. How many lines of the data and what is the length of that particular data. That is the use case I'm going to drive. Cat input.log file. How many lines of the data we have? 211 lines of the data we have in the same file. Okay, so to drive this use case, look at here, all of you. First use case I'm starting. Sir, I'm saying at the Scala prompt only where some file is equals to SC. What is SC? I already mentioned. Spark context is the main entry point for our Spark core use cases. So SC dot, I am using the method called text to file. Now in the double quotes, sir, if at all you have to read the data from the local file system, you have to say file : /. To read the data, to read or write the data from or to local file system. We are going to use file : in the similar way, HDFS. So that's how we are going to use it. So it's a notation, sir. Now from the local file system path only, I'm going to read the data. I'm saying, sorry, /home Gopalakshna /spark /pack input.log file. Yeah, this is known as the base RTD. Okay, there is a file we are reading. So it has been coming over here. So this is nothing but, look at here, org.apache.spark.rdd of string. This is known as the base RTD, where some particular map file, I'm using another variable, file.map. I'm using a map transformation. X implies that x dot length. Every length of the line only I wanted to see. Okay, yeah. So, sir, length is always going to return the integer value. That is why RDD of string has been changed to RDD of integer. Sir, I mentioned very clearly, when you apply any transformation, the outcome is a new RDD. So the source RDD is RDD of string. Again, it is going to provide one more RDD only. Of course, in place of string, we are getting integer here, but result is always RDD. What is map? I already mentioned. Map is one of the default, one of the transformation only. So when you apply the map transformation, we are getting one more RDD. Okay, now map file dot collect. So I'm directly calling the collect. What is collect here? Collect is one of the action. So now look at here. In a bottom to top fashion, you need to collect all the lengths of the 211 lines of the data. So you are collecting the data where map file. So internally, what is happening? Where is map file? Yeah. So where is the map file? It is going to this particular statement. Here only we are actually doing the transformation. In the map file, you are getting from the file only. You are trying to map the string type of the data to length of the data. Where is this file object? Yeah, so bottom to top approach, step 3 to 2, 2 to 1. Okay, so here if at all, sir, 1 minute, sir. This is the step 1, step 2. Okay, so this is step 3. So indirectly, the processing will happen. Collect is a action. So where we are applying the collect action on the map file. Where is the map file? Here. Here in the map file, what we are doing, there is a file object. From there, we are trying to map the lengths. So where is the file object? It is going to this one. So likewise, bottom to top approach. Okay, so now here, if you look at the path, there is no such path within the Spark pack. So if you look at the other way in the other window, what is the path? If you look at closely, within the Spark only Spark is there. But here, what I'm referring, within the Spark pack, I swapped the directories. Even though the input file is not available in that particular path, is it throwing the error? No, because it is not actually starting the processing at this point of time. No, it has not started the processing here. So without having the input file over, how it is translating the string type of the data to length, here also it is not happened. From the step 3 only, it is going to the map file. From the map file, it is going to the file. Now it is trying to load the input file. So what is going to happen at this point of time? Now it will throw the error. Perfect. Look at here, invalid path. Invalid path. Input path does not exist. But why this error is coming here? Why not here? The moment you are providing the path, it should also come over here, right? The path is not available because Spark is not starting the processing at the very first base RDD level or a transformed RDD level. The processing is only starting once you invoke any action only. So then only it will go in a reverse order only from step 3 to step 2, from step 2 to step 1. Then it is realizing this error. So it is a clear example of lazy evaluation processing of Spark. Sir, are you clear?
Yes, sir. So in the top to bottom case, first time itself you should get an error, right? Got it.
Okay, so one more point I will show you. Those though you don't know map reduce and all people who are not aware of, not an issue. So just look at here what I'm showing here. Sir, we have a path. Okay, I'm going to provide in HDFS only. There is no such directory. This is what my HDFS path I'm referring. Yeah, MR out 138 only we are having. Is there any directory called MR input 500? Is there any such directory? Does not exist. Clearly it is saying. Okay, so now you look at here. There is a jar file here, batch 138 word count.jar file. I'm running one particular command, yarn space jar. What is the driver class name? Word count new driver. This is a syntax we have to follow, sir. MR input 500 slash input.log file I'm referring slash MR out 500. So the moment I say enter, so here the processing has been started. Some messages, whatever I have given in the system.out.println, those messages are coming, and at the very beginning only it has been realizing invalid input path exception. Input path does not exist because MapReduce is doing the top to bottom processing this way. From the top only, it is not doing any kind of, it is not accepting any kind of the other mapper phase or nothing. At the very beginning only, we are getting this particular error at the beginning only. Whereas in our Spark, you only observed, though the path is not available, here it is not throwing any error. And you are applying a transformation also not throwing any error. But the moment you call the collect action, then only you are going, meaning in a reverse to, in the third step to top step, it is moving at that point of time. And then it is saying, boss, this path is not available. I'm not able to read that particular path. Hope you are clear now. So MapReduce is top to bottom. Spark is bottom to top approach. It's a clear evidence. Yeah. Now, sir, you need not to do all the things, but for your clear, observation point of view only, I'm giving you again the same thing now. Oh, my bad. Sorry. I will correct the path. Within the pack only we have Spark. Yeah. Now you're applying a transformation. Now you're applying the action. Is it throwing the error at this point of time? Because the path is available and input file is also available. We are getting the total length here, something. And if at all, how many particular elements we are having, how many lines of the data we are having, if at all you are using the count action, 211, perfectly we are getting. Okay. So this is how in a bottom to top fashion only, the processing has been carried out in our Spark. Just take a snap. Here file object is a base RDD. Here map is a transformation. Collect is a action. Count is a action, something. Okay. Let me proceed, sir.
Hello, sir.
Yeah.
So here actual processing happening in third step.
Yeah. So here in the third step only we have given the action. Yeah, collect. It is another action, count, where you are applying the count action on the map file. It will go to that map file. Then it will take, it is saying file.map. What is there in the file? Yeah, 200 lines it has been taking. That length only you are getting. How many such elements we are having? 211. That's how we are getting. Clear, sir?
Yes, sir.
Yeah. Now second use case I'm moving. Okay. Now so slightly I'm changing the transformation. I don't want to just see only the lengths only. I want to see the file, or the line, and that particular length. If at all I'm providing a line, what is that line and what is the length? So string comma integer. That's how I'm just tuning this particular transformation. If you pass RDD of string, we are getting RDD of string comma integer. Okay. Yeah. Now map file dot collect. Okay. So now you are getting the perfect output. Hadoop is big data tool 22. The line length is 22. Hadoop is good for storage and processing. Line length is 41. So it is a paragraph kind of one it is showing. But if I wanted to see in a line by line fashion, then what we are supposed to do for each println, we have seen in our scale predominantly map file dot collected for each println. So all the things will come in a line by line fashion. Look at here, sir. Every line, what is the length? You are getting perfectly. Okay. There are some empty lines also there. That's where it is giving the message comma 0. The line length is 0. Yeah, please take it, sir. Sir, are you able to follow?
Yes, sir.
Yeah, next. Sir, sc.text file I'm using, that is a default method. Now the same map transformation I'm going to provide where data is equals to, this time I'm using a method sc.parallelize. So what exactly parallelize stands for? If at all you are providing the data, not a file object, if you are providing the data manually as a list or set collection, in order to apply the parallel processing, we are going to use sc.parallelize. If you are going to provide the data list of yeah, so this is the data I have given something. Now where map data, so data dot map, what I'm giving, x implies that x comma x dot length. If at all I'm providing the data here, so same funda. Now map data dot collect dot for each println. So every string, what is the length of that particular string? Yeah, look at here, sir. Perfectly we are getting. Now as I am providing the list collection data, to apply the processing only we have to use sc.parallelize. Whenever you are reading any file, you have to use sc.text file. If you are providing the data, we have to mention sc.parallelize. Take it. Okay, are you done, sir?
Sir, one question. If we declare again var data with additional values, will that add to here override?
Yeah, every time if at all you are going to say, now you are going to say a new data I'm going to define something like here. So new elements. Now it will take this new data only. It will override the previous data. Whatever is there in the active scope now, that is only be taken. Okay.
Okay, sir.
Yeah. Now. So the same map only I'm using, but a slightly different use case. I would like to see. By providing that every string, I want to see the string, reverse of the string, and length of the string. Look at here from the string RDD of string only, how the data is being converted. RDD of string comma integer. Yeah. Okay, next. SC dot parallelize. So here you should not say list of or something. 1 to 20. It is a range collection, inclusive range. So you are saying something like this, and followed by yeah. Please take it, sir. This use case also. So wherever you are using the map transformation, basically it will convert your data from one format to another format. So the basic functionality of the map transformation itself is to convert your data from one format to another format. Sir, are you clear with the map transformation?
Yes, sir. Sir, one thing, like in the SC.parallelize, currently we are directly assigning the values or something. If I want to pass there in the runtime or suppose any variables, then directly I could add the value name, or how it is the syntax?
In the standalone mode, you cannot pass the runtime values, sir. But however, in the batch mode only, like you will define, our argument 0 is the input, argument 1 is the output, and while you are running the Hadoop yarn command, there you can runtime only, you can pass that what is argument 0, argument 1, and everything. Those things you can do.
Okay, so that not supporting the standalone mode. Okay.
Yeah, correct. Next. Sir, I'm reading the same file. Now I'm going to use some filter example, file.filter. I'm simply saying x implies that x dot length. If at all it is above 50, only that particular data greater than or equal to 50. Only that particular data I wanted to take out. Okay, not all. Sir, in the original file, what is the count? File dot count. Totally 211 lines we are having. But when I say filter file, how many lines of the data we are getting? Only 21. Above 50. But I would like to see that particular data. Then you know very well. Collect dot for each println. These are the above 50 lines, 21 lines what we are getting. Sir, okay, once you clear the screen, everything is going out. So that is why I would like to see these results in a separate file only. So how can I do that? 1 minute, sir. In the home Gopalakrishna path only. Is there any particular SP out? I'm trying out CD SP out 125. Is there in such directory? No, as of now, there is no directory. So now look at here, all of you, please. Dot save as text file. Yeah, now I'm going to file : / what is the path? Home / Gopalakrishna / SP out 25. Yeah, done. So now if I go back to that particular path, if I say the same command again, CD SP out 25, now this path is available. Look at here, it is created. And here we are getting the 2 part files. The entire data has been divided into 2 partitions, because by default, we have seen in the architecture also 2 partitions are there, 2 tasks are generated. So likewise here also 2 partitions we are getting. When I say nano part file, first file, only few lines we are getting here, and in the second file, another few lines we are getting here. So this is the way our data has been saved in the text file as well. Using a save as text file option, we can store the data as well. Okay, so now I will do one thing, sir. As of now, what are the transformations and actions we have covered?
Sir, in the files, I can see SRC extension files. What is it?
CRC, sir, cyclic redundancy check. Not SRC, it is CRC. Cyclic redundancy check. These are the internal files only, not meant for us. Some hidden files, everything is starting with the dot.
So each task it will generate for each task?
Correct.
Okay.
Covered transformations and actions. Yeah, so what are the transformations that we have covered so far? The very first one is map filter only we have covered. As of now, actions, collect, count, save as text file. So these are the actions we have covered. Okay, so let me stop the session here, sir. So rest of the things we will discuss next week only. next Saturday only. So meanwhile, please all of you, what I have observed, I'm not saying all, but majority of the people, you are yet to download the given files as well. That is something bad. The front office team has shared all the respective material and all. So you please download, and using WinRAR only you can extract, and you do the installation, because we have shown in the couple of other missions also what you need to do. So please complete these activities and start the practicals immediately. Otherwise, you will not digest the subject perfectly.
Sir, virtual machine it got installed, but I can see no options in the virtual machine. No options in the files.
Okay, 1 minute. Let me make you the
Can you please
presenter.
repeat, sir?
Show me like what you are saying. You didn't understand.
I can see my computer and shared VMs options.
Here only you have. That's what, sir. You are not understanding. Click on the open a virtual machine, middle one. I told you, in the home tab only, the middle one you have to double click. Go to the Spark and Scala image where you have extracted. Yeah, that is the
Plain
image. Yeah, plain image. Yeah, please clear symbols. Here it is showing as memory as 4 GB. That's fine. You can now power on the virtual machine. What is that, sir? I think the extraction of the image has not happened properly, it seems. One more time, you please extract that Spark and Scala thoroughly, and then you browse the same file. It's the same.
Okay, sir. So once it got installed, and if I type Scala, then I will enter into the Scala prompt, and Spark Scala today will discuss the same procedure, sir.
Same. Yes.
Okay, sir. I will do that.
Yeah. Thank you.
Sir, could you please share this architectural document today, or it will?
Yeah, you will get it by tomorrow EOD.
Okay. Okay. Thank you, sir.
Thank you, sir. Thank you all. Have a great weekend. Wish you all a very happy Ganesh Chaturthi. Catch back next Saturday. Thank you, sir.
So thank you.
So next Saturday 7 a.m. or 6:30?
6:30 only till the end of the classes. 6:30 only the time.
Okay. Okay. Thank you, sir.
Thank you.
Okay, sir.